I'm calling this guided kinematic 4. A bike accelerates uniformly from 3.1 meters per second over a distance of 35.4 meters in 10 seconds. What is the bike's final speed? So let's visualize the problem. And that's pretty much the best bicycle I can draw. I'm assuming there's a person riding that bicycle, but I don't feel like drawing that much, and the problem doesn't mention a person. Anyway, it accelerates uniformly from 3.1 meters per second. It's accelerating in the same direction, and it travels from a position of 0, xi equals 0, to a position of 35.4 meters. So it ends up here after traveling, and that happens in a time of 10 seconds. So do we have to convert anything? It looks like everything is in correct units, meters per second, seconds, meters, so we don't need to convert. Next, we need to write down our knowns and our unknowns. We've pretty much already done that. Initial speed is 3.1, initial position is 0, final position is 35.4, the time is 10. What we're looking for is the bike's final speed, so VF equals question mark. Next, we need to, and we also don't know the acceleration, but the problem doesn't really mention acceleration except to say that it accelerates uniformly. Next, we have to figure out which kinematic we want to use. So we're looking for VF, we have VI, we do not have acceleration, but we do have time. So let's go back to this kinematic to see. Number 2, we have our XF, we have our initial position, we have our initial speed, we have our time, but we're looking for final speed, and I don't see VF anywhere in this equation, so we don't want to use number 2, it looks like. How about number 3? Well, we're looking for VF, so we want to see that variable in there. We have VI. We do not know what the acceleration is, but we know what our final position is, and we know what our initial position is. So let's go back to that one. Okay, kinematic number 4. We have our final position. We have our initial position. VI we know. VF is what we're looking for. So as I was saying earlier, we want to look for an equation that contains that variable, and we have our time. So it looks like number 4 is the one we want to use. So let's copy that down. So then we plug in the variables and check through the algebra. So XF is going to be 35.4, XI is 0, VI is 3.1. VF is what we're looking for, so we just leave that as a variable. And then T is 10. So the first thing I'm going to do is just do the 1/2 times 10, and that is equal to 5. Then I'll go ahead and distribute that 5. Then subtract 15.5 from both sides. Then divide both sides by 5. I almost started giving you the units there. You should be familiar with them by now, but we end up with 3.98. We found speed or velocity, so the units will be meters per second, and we circle our final answer. Now, one thing I didn't mention in the other videos is that when you get your final answer, you should think about if your final answer makes sense or not. For example, for this first one here, how long did it take the bus to slow down? We ended up with 4 seconds. So 4 seconds, that makes sense. If you're in a bus, it's going to take a good long while to slow down. 12 meters per second isn't that fast, so it seems to me that 4 seconds is a good approximation. If you got something like 300 seconds, it's not going to take the bus several minutes to slow down. For number 2, that's number 3, but we can talk about number 3. A driver of a car traveling at 15 meters per second. We got that he didn't slow down for 55.25 meters. Obviously, his car doesn't have very good brakes because 15 meters per second, that's about 30 miles per hour. So it seems to me it should not take that many meters to slow down. But it still makes sense. You didn't get something like 3,000 meters. It definitely would not take 3 kilometers for this car to slow down. Problem number 2, that was the runway problem. So, and we ended up getting 1.7 kilometers. So it definitely makes sense that a runway for a plane would have to be pretty long. And then for this last one here, the bike was only accelerating for 10 seconds. So it makes sense that his speed would not increase that much. His speed increased from 3.1 to 3.98. So again, you should always think about whether your answer makes sense in the physical world when you get your final answer.